Hi there, welcome back fellow stats enthusiasts. For those joining us for the first time, my name is Bronwyn and I lecture in the Department of Industrial and Systems Engineering at CPUT, and this is part 4 of a set of screencasts. If you haven't seen the previous 3, I encourage you to watch those first, as it might be easier to follow this one, but it's not mandatory. If you don't mind, I'll remind everyone again that these screencasts are part of an open educational resources project at CPUT, so please watch it as many times as you need to. You can download it, share it with your friends, and tell everyone about our open education resources project. So let's get started with part 4, shall we? In part 3, when we finished, we were looking at ways to present data. So we had looked at 2 statistical tools. Those were the pie chart and the leaf stem plot. And those were 2 tools that can be used to summarize and communicate data that is easily understood by users. In this screencast, we will look at more tools, namely the scatter plot, a time series plot, and a box and whisker plot. And to understand the box and whisker plot, we first need to understand quartiles and the interquartile range, but we'll do that as well. Okay, so let's begin with the scatter plot. The interesting thing about a scatter plot is each individual item in your sample needs to have 2 data readings, or a paired set, in other words. One data or observation on a particular item that is selected in your sample will be from one variable that is important to your study, and the other observation, the paired observation to the first observation, also belongs to that particular item or individual in your sample, but it will be on the other variable. Now I've got to first stop here and explain what a variable is. A variable is a characteristic of interest, so it's something you're interested in, and that's why you're conducting the study. And more than that, a variable, the name variable, actually gives us a clue. A variable is something that varies. We expect a variable to change, even in the same person or in the same item that we measure, from time to time that we measure it. And more than this, there's different types of variables. There's an independent variable and a dependent variable, but that is not of consequence for this particular screencast. I'll go into depth on that later when we do more inferential type statistical tools. A scatter plot is a descriptive tool. So what we essentially do with a scatter plot is we look for a relationship, whether there is a relationship between the 2 variables or not, by organizing and presenting the data on a scatter plot. And once that has been done, then we can communicate. We'll be able to see for ourselves and we'll be able to communicate if a relationship between the 2 variables exists or not. And we'll see that if there's a line or if there's no line that forms, once we've plotted the data, of course. So here's an example of a scatter plot, and it's data collected from students. And over here we can see these are the students. There are 1, 2, 3, 4, 5, 6, 7 students. And we can see, as I mentioned, there's data on 2 variables. Now the variables in this example is absences, namely the days absent, and the mark or the grade that the student obtained. And for each of these, the same student has got a number of days that they were absent and a grade that they obtained. And so we put these on an X and a Y axis to be able to see if there's a relationship between the 2 of them. For each one of these students, we will find where it is on the X axis, I beg your pardon, I'm sorry about that, and we'll make a mark there, and then we'll find the corresponding value on the Y axis. And as you can see, we can immediately pick up that there is a relationship. And basically what this scatter plot is telling us is that the more days the student is absent, the less the marks are. And so that is how scatter plot is used. Pretty simple and straightforward, isn't it? Okay, so the next thing we're going to look at is a time series chart. And this is even easier than a scatter plot. Time series chart, I've heard people refer to it as as a run chart. And what this essentially does is it plots data over a period of time. So in this example, I have the following table lists the number of minutes Bronwyn used a cell phone for the past 6 months. So in January, I used it 2:36 minutes, February 2:42, etc., etc., etc. And it's easiest for me just to explain by showing you what a time series chart looks like. All you basically do on your x-axis is have the months as they follow, and then basically plot for each month. It's very similar. The principle is very similar to a scatter plot, but you expect it to demonstrate things in terms of time. So for that particular month, for February, I used it so many minutes, for March, etc., etc., etc. And so now we get to the fun stuff. To be able to do the next statistical tool, descriptive statistical tool, the box and whisker plot, we need to understand quartiles, which is what the next slide is about. To calculate quartiles, we use something called the median. Now, the median is one of the 3 characteristics of central tendency, and that's something that I'm going to discuss in greater depth in Screencast 5. There are 2 others, namely the mean, also known as the average, and the mode. But for this screencast, it's just the median that we're interested in. And simply put, the median is the central or the middle data point in an ordered, and that's very, very important. It needs to be an ordered set of data. To obtain the median, we arrange our data either in ascending order or descending order. It doesn't matter, but if you are wanting to work out quartiles, then ascending order is better because you're going to have to work out the interquartile range afterwards, and it just works so much easier if you do it in ascending. It makes your life easier if you do it in ascending order. So quartiles, as the name suggests, is what divides your data into quarters or 1/4. So let's arrange the data. Now we look at this data set over here. This data set is a simple data set. It consists of 5 numbers. So it's 0, 25, 50, 75, and 100. And it's already arranged in order for us here. To work out Q2, we take the center number, and that would be the median. Between these 5 numbers, the one in the center is number 3, which in this case is 50. And then to work out Q1, we take the lowest number and the center number between the lowest number and Q2, that would give us Q1. The same applies for Q3. To work out Q3, we take the median or Q2 of the entire data set, and we'd say what's the highest. We'd establish what's the highest number, and the number in the center would be Q3. Between the number in the center of the Q2 and the highest data observation would be Q3. Okay, so looking at a simple example, let's actually consider it on a more complicated example. The quiz scores of 15 students is listed below. Now we need to find the quartiles. So they specifically saying find the first, second, and third quartiles of these scores. So it's Q1, Q2, and Q3. The data that we first given is not given to us in an ordered way. As you can see, there's 23, then there's, I beg your pardon, 28, then 43, 48, 51, and then we're going back down to 43. So this is not yet ordered. The first step that we then do is we order this data set. And there's 15 of these students, which means data point number 8. So 43 is number 8, that's the data point that's in the center, and that is the second quartile. That is Q2. Then to find out what Q1 is, we take the lowest score, and now what we find here between data point number 8 and data point number 1, it's actually Q1 would actually be in between these two, but because they're both 37, Q1 is 37. And that is the median, that is the middle point between this observation and that observation. In between this observation and the median, there are 3 data observations. In between this observation and the median, there are also 3 data observations. And if those weren't both 37, you would add the 2 and divide it by 2 to give you what the median is. And we do the very same thing for the upper half. So this is the first quartile, this is the second quartile, and this is the third quartile. So the next thing that we're going to look at is the interquartile range. And the interquartile range is really very simple. It's the difference between the third quartile and the first quartile. And it gives us an idea of the spread of the data. We expect most of the data to lie in that interquartile range. Using the previous example of quiz scores, we found that the third quartile was 48 and the first quartile was 37. So we simply go 48 subtract 37, and that gives us an interquartile range of 11. So now that we know what quartiles are and what the interquartile range is, we can construct a box and whisker plot. This type of plot or chart uses quartiles and the interquartile range. And the box is, in fact, the interquartile range. The ends of the box are indicated by the third quartile and the first quartile, and the center of the box is the second quartile. The entire range of the data set is what the whiskers indicate. So we are basically going to use a 5-number summary to draw our box and whisker plot. We're going to use the minimum number. Then that would be the end of the lowest whisker. We're going to use Q1 or the first quartile, which will be the start of our box. We'll have our Q2 or the second quartile, which will be in the middle of our box. Then we'll have Q3 or the third quartile, which will be the end of our box. And then the last whisker is the highest data point that we have. And using the data set that we were looking at earlier, we'll see the minimum entry was 28, the Q1 was 37, 43 was Q2, Q3 was 48, and 55 was the maximum entry. And so this is what our box and whisker plot would look like for that data set. And so I just want to end with the steps to do in a box and whisker plot. The first thing that we do is we order the data. So from in ascending order, from the lowest to the highest. That is what I would advise. Then you find the median or the quartile to the second quartile, which is the median of the entire data set. Once you take that median out, you then look at the remaining two sets and you find the median of those two sets on either side of the second quartile, and that will tell you what your first quartile is and what your third quartile is. And then to actually draw it, you set up an accurate scale. So the scale really must be accurate, and then you start by drawing your box. You indicate where quartile 2 is. That's inside of the box. It doesn't necessarily have to be on the scale in the middle of the box, but it is inside the box. And the ends of the box are quartile 1 and quartile 3. Then you draw the whiskers, extending the lowest whisker ends at the lowest point that you have in your data set, and the highest whisker extends until the highest point in your data set. The last thing I just want to point out is if your data is skewed, left skewed or right skewed, if your average is not in the middle of your data set, then the center, the quartile 2 won't be in the center of the box. It will be either on the left or the right, depending on where that is. But in a later screencast, we're going to discuss the skewness of data. And so that's all for now, folks. Thank you so very much for joining me again for the screencast part 4. And I'm going to be looking forward to chatting again in our next screencast. Bye.